Hello all, I am Shankar from 3ITB. Hello all, I am making this video to explain about backtracking and to explain NQueens problem. So coming to backtracking, backtracking is one of the most general algorithm design technique, and it is mostly used for searching the solutions and searching for an optimal solution. Um, we definitely we cannot say the optimal solution. um, we can say that we can find a vector in this, so that means which consists of a number of solutions. It may be 1, 2 or more. So as shown here, um, we express it as x1, x2, x3 and so on xn. So here xi represents 1, 2, 3 and so on, and it can be said as a finite set. So coming to backtracking, as we said before, backtracking is a design technique, and here uh, when we go with some constraints and we try to find a solution. If that solution uh, if that solution uh, obeys all the constraints, and we can say we can consider it as solution. If if that solution does not obey all the constraints, we cannot take it as a solution in our vector. So coming to backtracking, if it is a sequential process, and in one step if we cannot get any solution, we can go back to previous step and we can change our mode. That means uh, um, that means if in some path, if we cannot get a solution, that means if going in a sequence performing three or four steps, if we cannot get any solution to add in our vector, we can move previous step. That means we can backtrack our solution and change the inputs or some inputs in previous steps. So in this way we perform backtracking and we get some solutions. And one of the application of this backtracking technique is NQueens problem. So coming to this NQueens problem, let us see this. See, uh, NQueens problem. Mainly NQueens problem is placing some queens in a chessboard, n into n chessboard. If the value is if the value of n is 4, and so that means we take 4 into 4 chessboard and we place 4 queens with based on some constraints. So coming to constraints, see, this are the constraints of this uh, NQueens problem. So see, with NQueens problem example, consider NQueen problem. The goal here is to place n queens on n into n chessboard. As we discussed earlier, we have to place n queens in n into n chessboard, so such that no queens attack each other. So attack each other means we cannot place a queen beside a queen, and we cannot place a queen diagonal to another queen. So those come under these constraints. So see explicit constraints. Each row and column must have exactly one queen. That means see, each row and each column contains only one queen. No two queens come into same row or same column. It is an explicit constraint. Next implicit constraints are: no two queens should be on the same diagonal when placing each queen. So what it is saying is, so we have uh, queen q2, that means queen 2 here, and we should not contain queen 3 here diagonally, and same like this side also we should not contain queen 3 here. So this is one of the explicit constraint. Next step, if there is any conflict, that position is skipped in the current recursive steps. That means if we have any this type of, so as previously discussed, if we have this type of situation, if there is any conflict, this means here conflict means nothing but placing a queen diagonally to another queen. So uh, it is here placing a queen diagonally to another queen, it's a conflict. So if we get this type of conflict, we make this type of solution as no solution. That means we does not consider it to our vector. Vector is nothing but previously discussed xi to xn. So next, so let us do this n queens problem with 4 queens. So coming to n we take 4 queens, q1, q2, q3, q4. So we consider it as 4 into 4 chessboard. So when placing q1 here, and let's place q2. In next step we place q2. So for placing q2, we should not place in this row, in this column, and we should not place in this row as per our constraints. So we does not place q2 in this position. That is nothing but let us consider 0 1 2 3, 0 1 2 3. In the position 0 0 we have q1. So in the position 0, I mean 1 0, we cannot place q2. And coming to 1 1, so here we cannot place q2 because it is diagonal to q1. So coming to this position, that is 1 2, 1 2, it is not diagonal to q1 and it is not in the same row, same column of q1, so we can place q2 here. And next coming to step q3, to place q3 we cannot place in this column and we cannot place in this row. So let us check for this position. It is nothing but 0 1 2 2 1. So in this position we cannot place q3 because it is diagonal to q2 and it is diagonal to q2. And coming to this position, that is uh, 2 2 2 2 2 2, here also we cannot place this q3 because it is in the same column and same column of q2. As per our constraints we cannot place here q3. So coming to this position, that is 2 3, here also we cannot place this q3 as it is diagonal to q2. So we cannot go to q4 to place q4 as we did not place q3 in our chessboard. So this we consider as no solution. That means we does not consider it to our vector. And so how here backtracking takes place, let us see this. So while in q3, so that means we cannot place in any position of these 4 positions. So let us backtrack. That means we go to step 2, that means q2. While we place here, we place q2 here, that means 1 2, okay, 1 2. If we change this place to 1 3, see, let's check. If we place here, we can place q3 here, but we cannot place q4 here, here and here. That means we cannot place in 2 0 q4 because q1 is in the same column. We cannot place q4 here because if we place q3 here, I mean q3 here, it will be in the same column. We cannot place q4 here because it will be diagonal. And here also we cannot place q4 because it will be in same column of q2. So if we also change the q2 position, we cannot place q3 and q4 in this chessboard. So we change to we change the position. That means we backtrack to q1 and change the position of q1. So let us discuss it here. So coming to q1, we changed it to position 0 1. So when we place in this position 0 and 1, 0 1 0 comma 1, we can place q2 here, as it is not diagonal to q1 and is not in the same column or same row. So we can place q2 here. That means 1 3 1 3 we can, in 1 3 we can place q2. So coming to q3 we can place in this position, that is 2 0 2 comma 0 we can place q3, because 2 comma 3 we can place q3 because q3 is not in the same column or same row or diagonal to any other of the queen. So we placed q1, q2 and q3 also. So next coming to q4, we can place q4 in this position, that is nothing but 3 2 3 comma 2 we can place q4, because it is not diagonal to q3 or q2 or q1, and it is not in the same row of q1 q2 q3. So this is our here we placed all the queens, as we taken 4 queens problem. q1 q2 q3 q4 are placed here. So this is our required solution. We can add this solution to our solution vector. So in this way we can work out with 5 queens problem, 6 queens problem, 7 queens and 8 queens, and up to n queens. We cannot say the limit of this n queens. So to understand more better, we frequently work with only 4 queens problem. Thank you.